doing is that since we can select any value between them, so we will be seeing if the value of AI is greater than the value of bi plus 1. What I mean by that is basically, for example, um, let's say there is an array here, and there is another array here. So let's say I'm just taking two elements for right now as an example. So for us, in order to make sure that
And the
monocrop is
number of
winning,
questions that he
this
will
is
have
for the
solved
monocrop,
during
and
that
this is for
day will be added to his
stereocrap.
total
Okay.
score.
So what we'll be doing is that we'll be making sure that between these two, let's call this B2, and let's call this uh, A1. A1 must be strictly greater than B2. Why do I say so? Because see, if we select A1 for monocrop, the value for the number of problems that monocrop will solve will be greater than that of monocrop, because the second one, because B2 is lesser than A1. Thus, the number of the difference will increase. Right? What is the difference between both of them? A1 minus B2. Right? And we can generalize this by saying AI should always be greater than BI plus 1. So this will be the main idea behind this question, main idea behind the solution for this question. Um, does anyone have any query right now? Any issues? Okay, so I'll just proceed. So we can also see that if we select the last element, it will always be like good for us, because see, if we select the last element, stereocrap can't just solve any more questions, right? Because there is no bn plus 1, right? There are only n elements. So it will always be beneficial for us to solve this question. And for the rest, we will have to check this condition. So the implementation is here. We will taking the inputs. And if AI is greater than bi plus 1, then answer plus equal to bi minus ai plus minus bi plus 1. And at the last, we will be selecting this because it doesn't matter whether what is the value of this an minus 1, because it will always be beneficial for us. And then we will output the final value. Anyone having an issue? Okay, so we'll be proceeding to question number 2. You can also drop any doubt if you have in the comment section in the like, chat area. Okay, so question number B. Monocrop decided to. So basically, what in this question is stating is that Monocrop will be going on a journey. He will be traveling A kilometers at first time, and the first day. B and then B on the second day, C on the third day, and then A again on the fourth day, B again on the fifth day, C again on the sixth day, and so on. It will continue forever until unless it reaches N. Always remember that the cycle will take place A, B, and C. You can't just choose any random value like it will only be traveling B or C. It will be having a cycle. First it will travel A, then it will travel B, then it will travel C. Now we have to output the number of days it will have to travel so that it at least covers the n kilometers. We have to output the minimum value for it. Basically, the day in which it will have crossed the or reached the n-kilometer mark. So what we'll be doing here is that we will be checking how many cycles we require. What do I mean by cycle? So A kilometer will be traveled on the first day, then B kilometer, then C kilometer. So what we'll do is check how many times such cycle will take place. So for that we will divide n by A plus B plus C, thus giving us the number of cycles. And then we will check for the extra value, if there is any extra value for A, B, and C. So yeah. So, is the idea clear to everyone, or should I re-explain it? Okay, so I'll be moving on to the implementation. So what we'll be doing is that we'll be dividing n by a plus b plus c to get the number of cycles. I've directly stored an answer. You can also like type different variable names and do it if you want it to be more convenient to the eye. After that, we will check if it is greater than or equal to n. It will only be equal. It will never be greater. Although then we will multiply it by 3. Why will we multiply by 3? Because in each cycle it will travel 3 days, right? Then we will check for a. If it exceeds, for example, if this doesn't satisfy, then we will be moving on to this, although return was not needed here, but still fine. So we'll be adding 1, and in the second, for example, if this also doesn't satisfy, then we'll be using b, and just in case I've added this. Okay, so this is if it completes in the cycle. Answer will be the cycles here, and if it requires an extra 8 one day, if it requires an extra 2 days, if it requires extra one day 3 day. Okay, so is the implementation clear, or does anyone have any doubt? Okay, we'll be moving on to question number C if nobody has any doubt. Okay, so what basically this question number C is stating is that you will be given three values n, m, and k. N represents the numbers that will be present there, number of numbers from 1 to n that will present. Okay, m will represent the number of arrays that will be there. You have to output values for each of the array. I'll explain it to you. Basically, what AI represents is, for example, there is they will give you a value, for example 2, and n value is 5. So the array will be 1, 3, 4, 5. There is an example. So there is n value 4 and AI is equal to 3. So the array will be this 1, 2, 4. If it was 2, then 2 will be removed. In place of 2 there will be 3. Basically we will remove one index and we will let others be still the same. Okay, and so there will be m arrays of such type, and there will be k distinct values. Basically what this k distinct values is that these values will be satisfied by monocrop. Basically what is happening here is that monocrop will be given m list of questions. This each array is representing the list of questions. A1 will be representing something, for example, the value is 4 and your A1 is 1, then the array is 2, 3, 4. Basically the question number 2, 3, 4 will be presented to monograph, and in order to pass he needs to solve all the questions. There is no exception. He has to solve all the questions. So for example, if A1 is equal to 1 and n is equal to 4, then he will have to be able to solve 2, 3, 4, and thus you have to output for each one of them whether it is possible for monograph to solve them or not. and we will be given the questions that monocrap can solve. Okay, there will be k questions which monocrap can solve. So let's check the first example. The number of numbers, the questions that will be present are four, meaning there will be one, two, three, and four as questions. And the number of possible list of questions that may be presented to monocrap will be four, and three will be the number of questions that monocrap can solve. So here is the array given to us: one, two, three, four. This basically means the first list of questions will contain every question from 1 to 4 except for 1. And in this case of second one, it will not be containing the second question. Rest all will be contained there: 1, 3, 4. In this case 1 to 4, and in this case 1 to 3. So this is the list of questions that will be provided to you, and this is the questions that you can solve. The number of questions that you can solve, not the list, the number of questions you can solve. So as you can see, monocrop can only not solve. He won't be able to solve question number two. Other than that, he can solve all the remaining questions. He can solve one, three, and four. So obviously he can't solve this one because one won't be present there. The list will be two, three, four. So since he cannot solve question number two, he will only be able to solve question number three and four. Thus he will fail. In case of list two, the missing question is question number two. So the remaining question is one, three, four. So he must be able to solve all the questions. So thus the answer for it will be one. And similarly for three, four, the answer will be not possible because both of them will contain question number two, which monocrop cannot solve. So the result will be 0, 1, 0, 0. 0 represents that monocrop won't be able to solve that question, and 1 represents that he will be able to solve that question. So now how do we solve this? As you can clearly see, each one of them will have n minus 1, each list will have n minus 1 questions. And it is clearly mentioned that all of them will be distinct. And in case of k, all of them will be distinct. This is a like key highlight here, that k and m both will be distinct. No, means the input that will be given alongside k, that will be all will be distinct. So like if all of the numbers will be distinct, so you can just see that there are going to be n minus 1 questions here. So at least the k value should be n minus 1, right? Otherwise, it won't be even possible for monograph to solve even a single list, right? I mean, it's clear, like, because it won't have the ability to solve that many questions. For example, let's say 1, 2, 3 is there. So if there is 1, 2, 3, m value, let's say m value whatever that might be, so each list will have n minus 1 questions, and let's say k value is 1, so it will only be having one question, the ability to solve, let's say, question number 1. So it won't be able to solve even two questions, so there won't be any list possible for which he will be able to solve all the questions, right? So thus for this kind of case, all the values will be 0, and if the value is k is equal to n, because there is a possibility for k to be equal to n also. So if k is equal to n, all the numbers are distinct. That means it has all the values from 1 to n. Thus, irrespective of whatever list you present to him, he must be able to solve all the questions present in the list. So for k equal to n, uh, greater than won't be possible because the input constraint is there. So for k equal to n, the answer will always be 1. And for k lesser than n minus 1, the value will always be 0. But the main twist comes when k is equal to n minus 1. In that case, we will be trying to find the numbers of m which will have the same missing question that monograph cannot solve. For example, let's say monograph has the let's say there are 5 questions, and monograph is only able to solve 4 of them, which are, let's say, 1, 2, 3, 5. And the list presented to him is, let's say, 1 is 3 and 1 is 4. What will this represent? This will represent he can solve 1, 2. So the questions which will be presented to him are going to be this, 4, and 5. And in this case, the list that will be presented to him will be 1, 2, 3, and 5. As you can see, Monocraft can solve question number 4 because he has only the ability to solve 1, 2, 3, and 5. Whereas this question contains question number 4, so he will never be able to solve this question. This, in fact, he won't be able to solve any list which doesn't has 4 missing, because it will be only having 1 missing. That means 4 will have to be the missing one. And if we see the second list, we can clearly see the 4 is missing, so it will be correct answer. So this is basically the intuition behind this solution. So let me show you the implementation. First of all, does anyone have any doubt regarding question number 3? Okay, then we will be moving to the implementation part. Yeah. So what basically I'm doing is, first of all, I took the input and then I've created a string which will be giving out at the last as an output. And then if the k is equal to n minus 1, in that case, I will be checking for the value which is not present here. So this is the code for that. And for I will be checking for every array, that if the q dot size, basically that is k only, if k is equal to n, then in that case just 1, as I told you before only. The only special case arises when k is equal to n minus 1. In that case, if the missing question is equal to the not, which is not found on the list, then we will be adding 1, otherwise it will be 0, and then we'll output the value. History. Okay, does anyone have any doubt? Okay, so we will be moving to question number D. If they are.
Okay, am I audible? Hello, am I audible? Okay, hi everyone. So I'll be discussing from problem number D. Share my screen. Okay, is my screen visible? Okay. So the problem D asks you that they're given an array of n elements, and you are asked the number of interesting pairs. Now interesting pair is defined like you will be you will take the sum of the array, then you will choose to I and j index, then you will deduct the two elements from the sum, and if that amount is greater than or equal to x and lesser than y, that is if that's amount comes in the range from x to y, then that is an interesting pair. So you are asked the number of interesting pairs. So let's take an example first. So here we have taken example. The array is 4 6 3 6. So the array sum is 19. So there are four interesting pair we get. Like if we take the pair 1, the 1 and 2, then the sum is 19, and we deduct 4 and 6, we get 10. That is that comes between 8 and 10, so that is an interesting pair. Like that we get four interesting pair. So we need to answer how many interesting pair in the given array. So basically from the question we get that we need to solve this equation. Like see, we need the number of pairs of I and j for which this value comes between x and y. Okay, so see, the first approach is iterate through the whole array to like pick 4 here, then check for the complete array. Like we pick 4, then like let wait. We pick 4, then we iterate like for 6. 2, we deduct 2, we reduce these two elements, then we get 10. So this 10 comes between 8 and 10, so this is an interesting pair. Then again we pick 3 and 4, then we do this. If this comes between x is this comes between the range x and y, then that is also an interesting pair. So like that we can proceed, but that is not more efficient. That comes n square solution, so we need to optimize our solution. So how can we optimize our solution? So we can reduce this equation to like we have this equation, no, so we can add this, we can change this equation to this. Oh, sorry, wait. We can change this equation to just so this equation is equivalent to the previous equation. So now what we can do, we can have another array of this sum and of sum and of difference of sum and each element. Like we like for this array the sum is 19, so we can have another array like this, sum of a0, sum of a1, this. Sorry, my board is not working. I left it. So we can have another array where we have the sum and difference of each element. Then like then the like we can have an array sum was 19. So if we can make an array uh, comes 15. Hello, hello. Sorry, my net was not working. Is my screen visible now? Hello. Okay, sorry. So yeah, we can have a difference difference of sum and each respective element in the position. Then we can have an array like this. So we got an array where each element is this. Now we need to check for each element here. We have x and y, so we can set the upper bound as x plus ai and sorry, lower bound as x plus ai and upper bound as y plus ai. Then we can check how many elements in this area are there which comes in this range, left and right, which we can check in log n time. So we have reduced our time complexity from n square to n log n. So this how we can proceed. Let me explain you by an example. So this is our difference array. So now for 4 the range becomes the lower bound becomes 12 and the upper bound becomes 14. So we can now check how many elements are there in the array which comes in this range. We can see there are two elements in the range now, so we can have two. We can add two in our answer like this. We can again check for 6 how many elements are there. We will have two elements like it. Like for 6 we can have, for 6 the upper bound becomes 14 and the sorry, lower bound and the upper bound becomes 16. So in this sense we can see there are two elements, so we can have two. We can add two in our answer. Similar way for 3 we can add, we can have our lower bound becomes 11 and the upper bound becomes 13. So in this range we can see there are two answers, so again we can add two in our answer. So again for 6 we can add 2 in our answer. So here our answer becomes 8. But here we have not the question asks you particularly for the pairs where I are less than j. So in other words it is asking for ordered pairs, but we are considering ij and ji both. So this means we have calculated our answer twice. So at last we can just divide our answer by 2 and we'll get our answer. So this is our solution. Let's see the implementation. So here I have taken the input of nx and y, then taken the array as input. Then we have found the sum of the whole array. Then we have made the difference array. See the sum, we have made the difference array sum and of its respective element. Then we have sorted the difference array as as we are by using binary search operations. So we have sorted the array. Then in the loop we have set the lower bound here. We have set the upper bound here. Then this line doesn't require. Then we have find number of elements which are greater than the lower bound. We have found that. Then we have found number of elements which are smaller than the upper bound. Then we have just deduced what numbers which comes in the range. Then we have added. Then at last we just substituted the answer by 2. So this was the solution. Any doubt, anybody? Hello, any doubt? Okay, so let's proceed to the next question. Question E. So in question E, you are asked, given a batch of Christmas trees has arrived at the largest store in Berlin, and customers have already come to the store wanting to buy them. So you need to decide the price of a tree. So they are given some conditions. there are n customers, and for each customers, two arrays are given, A and B. And AI, where AI represents that it is the at max amount which the customer will give you, and without a and give a positive review. Otherwise, and in the BI represents the maximum amount where the customer will buy the tree, but he will give you a negative review. Otherwise, the customer will not buy the tree, and you need to find the maximum possible earning you can earn by selling the tree. But there is a constraint that you can't get more than K reviews. So these are the constraints. Very important constraint is here there. AI is strictly less than BI. Okay, so let's take an example first, then we'll proceed further. Okay, so this case. So here this is the AI. So this is the A array. This is the B array. This is N. This is K. Okay. So here the maximum. So if we need uh, decide the price of the tree as 5, then if we decide that price of the tree as 5, then this customer will buy the tree. But since it is greater than this value, so he will give you a bad review. So again, for this, he will buy the tree, but he will not give a bad review because AI is smaller than 5 is smaller than AI. Again, in this case, he will buy the tree and will not give you a bad review. So here for the tree price equal to 5, he will the total number of bad review is 1, which is possible, and the earning is 15. And you can see that 15 is the maximum earning in the test case. So we can see that we need to find the amount of the tree in which we can sold the tree, and the negative review is lesser or equal to K. So kind of linear search type problem, but here is the issue that we can't thoroughly linear search here because the constraints are from 1 to 10 to the power 9. So we can minimize our search range. So we can clearly see that only we can check. We will only check for those values which values are given in the arrays. So I mean to say that the price of the tree will only be the value of the elements given in these arrays. The price may be 2, maybe 3, maybe 2, maybe 8, or maybe 3, maybe 7, maybe any of these values, but not a value that is not present is in these two arrays. That is clear. So is that thing is clear that the price will be only between among the given values in the array. It can't be any other value. Okay. So now we will check for each value the for each of the value, like for 2, for this case, for this case, like for 2, how many bad reviews are there? If the bad reviews are lesser than or equal to K, then we can consider it as our price range, price of the tree. Then we will check how many can buy the tree for 2, and then that could be our answer. Then for those, we will print the maximum of those possible answers. So how will you check that for any of these amount there are reviews lesser than or equal to K, and how many will buy the product? So for that, let us just sort the both arrays. For simplicity, we will sort both the arrays. Now see, let's check for 2. Now you can see that for the minimum of all these elements, for 0 review, all the buys all can buy for the minimum amount. Clearly you can see. For 2, there are no negative reviews and all can buy the product. So one of the possible answer is us 6, like 2 into 3 equals 6. Let's say next check for 5. Now for 5, we can see that as we have sorted our array, so from I till further, all can buy the product without any negative review. That is clear. So here 2 are those, so 2 can definitely buy for 5, 10, and we since we can have one negative review, so this guy can also buy the tree. So with one negative review, we can also have 15 our answer, as our answer. So let's check for 9. For 9, this guy can buy the tree 9, but for 9 we will be having two negative reviews in this here. Here this guy will also give a negative review. This guy will also give you a negative review. So 9 can't be a possible price for the tree, because then we will be having two negative reviews. So 9 is not possible. Again 9 is not possible. So for 12 there will be again two negative reviews which you can't have. So here the maximum possible price is, so these are the maximum, the possible earnings, and from this 15 is the maximum possible earnings, so 15 is our answer. Let's take another example so to clear the problem. Okay, is that thing clear? If it is clear, then I don't think another example is required. Okay, let's see the implementation. I will be explain you better in the implementation. So is my VS Code screen is visible? Okay. So we have taken input of NNK, then this line is not, this pair is not required. So we have taken input of the array A and array B here. Then we have just sorted both the arrays. Okay, so here I have told you now. So the minimum of all the values is always possible to buy. So here I have taken it answer. So here I have traversed all the elements of B, given array B. So here this x1 gives you, here the x1 gives you the number, the elements which are sm smaller. Wait, sorry. Here the x1 gives you all the elements in the array A which are smaller than bi, strictly smaller than bi. And here the x2 gives you the elements which are in array B which are strictly smaller than bi. So if here the difference means the negative reviews. So if the negative reviews is lesser than or equal to k, so then that buy is possible. Then that amount we will have in our answer. This n minus I is the number of person buying for that amount. Okay. So similarly, we have traversed the array A. The same thing we have did here, and finally we have stored the maximum in our answer and we have printed the answer. So you need to see a bit in the like upper bound cases. I will, let's take an example for the upper bound. Okay, so 3379 b equal, sorry, this is b, 2238. Okay, so let's check for 2. Now for 2 is it, for this value we the, this will always be our possible answer, one of the possible answers for this is, so this is also. So let's check for 3. So for 3, for this further value, these further guys can always buy for the value of 3. So we need to check here how many bad reviews we will get. Hello? हाँ. Oh, sorry. So yeah, this for this example, for the smallest values, the that that price will always be one of the possible answers. So we'll start from 3. So for 3, the further guys will can always buy the tree for that price. And if we check for these two guys, there will be two negative reviews, which we can bear because we can have at max three negative reviews. So for these three, the price is valid. So three can be an answer, and for three, all guys can buy the tree. So we can have 12. So for 8, we can check that how many will buy the tree. For 8, this guy can always buy the tree, and this can't buy the tree. So here we will not, these two we will not consider as negative reviews. Same for the 7, and for 9 it will buy the tree, and here we have one negative review. We can bear in here. Yes, yes, true. You have doubt.
या भैया एक बार इसे प्लीज रिपीट कर दीजिए ना.
कहाँ से कौन सा पार्ट, इम्प्लीमेंटेशन या फिर
हाँ बस ये इम्प्लीमेंटेशन में ये मतलब a इक्वल टू 2238 b इक्वल टू 3379 वाला प्लीज.
ए इक्वल समझा नहीं मैं, फिर से बोलो एक बार.
यही वाला, ये a इक्वल टू 2238 वाला और b
अच्छा
इक्वल टू
अच्छा
337.
अच्छा, ये मैंने जो ए दिया हुआ है ना, ये वाला,
हाँ जी
ये ए रे है ना, गिवन रे.
हाँ जी भैया.
तो इसको इसको मैंने सॉर्ट किया है, मतलब असेंडिंग ऑर्डर में रखा है. सेम फॉर द एरे बी.
नहीं
तो उसको
वो तो समझ आ गया, बट मुझे ये समझ नहीं आ रहा कि मतलब कौन सा मतलब पर्सन कौन सा ट्री बाय कर सकता है, कौन सा नहीं कर सकता. एक बार ये
अच्छा,
रिपीट कर दीजिए.
मतलब ये बात ये है कि ट्री एक ही है, तुम्हें उस ट्री का एक प्राइस डिसाइड करना है जिसके लिए तुम्हारा अर्निंग मैक्सिमम होगा. ओके.
हाँ जी.
तो तुम्हें एक ही प्राइस डिसाइड करना है. अभी जैसे if you decide that price of the tree to be 2,
यस.
then this all guys can buy the tree without any negative review. ये समझ आया?
हाँ जी.
तो तब दो दो करके 8, तुम्हारा अर्निंग होगा 8,
हाँ जी.
and negative reviews will be 0. So 8 could be one possible answer.
ओके.
So again for this 2 same, then for this 3 we had 12.
यस.
So for this 8 we will check that for this 8 this guy can always buy the tree. Okay.
दिस
And
8
for
मतलब ये नहीं समझ आया, 8 के लिए ऑलवेज बाय द ट्री मतलब.
मतलब 8 के लिए वो खुद तो बाय कर ही सकते हैं ना ट्री, अगर 8 दे के, मतलब 8 अमाउंट ऑफ रुपीज दे के.
अच्छा ठीक है.
सो 8 अमाउंट ऑफ रुपीज देके वो खुद बाय करेगा, और वो नेगेटिव रिव्यू नहीं देगा, तो वो होगा एक. और इधर फॉर दिस फॉर दिस this tree they can't buy the tree na, because the amount of the tree is 8, so this tree can't buy the tree.
हम्म.
So here the number of negative reviews for this case is also 0, but the amount we get is 8 for this, for amount equal to 8, for price equals 8, total amount will also be 8.
अच्छा अच्छा समझ गया भैया.
अभी समझा?
हाँ जी.
हाँ. तो ऐसे सभी के लिए चेक करना है, और इन वैल्यूज ये टोटल मैक्सिमम ऑफ द टोटल अमाउंट हमको रिटर्न करना है आंसर में.
ओके भैया.
Okay. So this was the solution for question E. Any doubt? Anyone? Okay, so the further Ayan Bhaiya will continue.
Hello, hello. Is my screen visible?
हाँ भैया.
Okay. So I will be explaining problem F and G. Okay. So first we have F. Uh, so we are given a deck of n cards. The position in the decks are numbered from 1 to n. Basically, the positions, there are n cards. They are in order. So we are given a joker which is at position m. So the mth card in the order from 1 to n, mth position has the joker in it. Then we are given q operations which are applied sequentially to the deck. That means like the ith operation comes before I plus 1th and so on. During the ith operation, you need to take the card at position AI and move it to either the beginning of the deck or the end of the deck. For example, this I will explain properly later. Then we are asked to calculate the number of distinct positions where the joker can be after each operation. So okay, so let's see. So it is visible, right?
हाँ भैया.
Okay. Okay. ठीक है, तो let's take an example. Initially, let's consider n equal to something like 6 or 7. Let's say 7. So we have 1, 2, 3, 4, 5, 6, 7. Okay. So let's say the car m is initially 5. So the joker is initially at fifth position. Then we have some operations. Basically, now let's consider an operation where let's consider three types of different types of operations. Initially, let's say initially operation is, wait a second. Okay, the operation, there are three kinds. Let's say the first kind is when the index of the operation, let's say x, let's say the operation is at index x and x is less than let's say this 5, x is less than 5. uh, X is less than 5, then there is the case when x is equal to 5, then the case where x is greater than 5. So when x is less than 5, let's say x is something like 2. So what can we do? Let's say this is the one that we will either, so we, the operation is basically we select, let's say here the operation is at index x. So we take the card at x and we either put it at the front or we put it at the back. So how will this affect our joker? So basically, let's say the 2th card, I am shifting it to the front. So basically, the new array will look something like 2, 1, 3, 4, 5, 6, 7 with the joker still at 5. You can see that the relative position of F, relative position of joker does not change. Okay, so when, okay, someone's mic is on. Can you turn it off? Okay, thank you. So okay, so we have you can see that when the operation is at the beginning, let's say when x is less than 5 and we put it at the front, the position of the joker does not change. We are asked to find the number of positions where the joker can be after an operation. Let's say what will happen when we put this 2 to the back. Okay, so now the array will look something like 1, 3, 4, 5, 6, 7, and 2. Now you see that the position of 5, the position of the joker, this was the joker. So the joker was at 5. Now the joker is at position 4. Okay, let's say it was 1, 2, 3, 4. So it is at position 4. So now we can also get the joker at position 4. So basically we have two possible positions after the first operation. One is at the same position that it was initially. Then the other one is it got shifted one to the left. Okay, so we can generalize this to something, let's say at some moment, okay, at some moment we have a range. Let's say we have an interval of positions that was possible for the joker in the I minus 1th query, in the previous query. Let's say these are the positions. Then what will happen if we have a query which is just before this range? Let's denote this range as L and R. Let's say X is less than L. That is, the joker is not affected by this thing. So basically what will happen, so if this thing goes to the front of the array, this LR remains the same, it does not affect it. But what if this goes to the back? If it goes to the back of the array, this L shifts one position to the left. So basically, if X is less than R, less than L, then the new range will be L minus 1 and R. So is this clear so far? Is it clear? Okay. Okay, so this is clear. So now let's consider the other part. Let's say we have LR. We have LR here. Then now the operation is at some index which is to the right of R. Okay, so that is X is greater than R. What will happen then? Since X is greater, so if we put it at the back, it still not affect our range LR, because the index of L and R is not affected, as none of the prefix is affected. So it's like index still remains the same. Now what if we put it at the front? If we put it at the front, basically we get one extra index which is possible, that is R plus 1. So when X is greater than R, the range will become L and R plus 1. Okay, so we see that with each operation, the basically this segment is just increasing sidewise, either once to the left or once to the right, depending on the position. If it's not in the range, let's say what happens when the other case is when X is in the range LNR. When X is in the range LNR, so this is the range. Then we have we have the element here. So when we have the joker, like we have some possible joker which we have to operate. We have to either put it to the front or we put it to the back. So this, you can see that this will lead to two extra segments. One of the segment will start from the front, which will be a new joker position. Then we had the ones in the middle, which is initially the one that we were expanding so far. Then we will have one to the back. So basically, at any moment of time, we can have three different segments of joker positions, which will be possible. So basically, now after the three segments are achieved, similarly, we can check now. Let's say in the next operation, we have the element to be moved here. So we have it here. So basically, we see this is a segment. This is the same case. This is the LNR. It is to the right. So basically, this R will increase by 1. Similarly, for this segment, this is LNR. It is to the left, so it will increase by 1. The L will decrease by 1. Similarly, for this segment, this is the LNR, so the L will decrease by 1. So basically, we will have three like active joker segments at any point of time, because after once we get three segments, basically, let's say even though we have one here, so either this we have one here, either it goes to the first segment or it goes to the last segment. So basically, we will keep expanding these segments until like basically with each operation we can have at max, like after this thing we can have at max two extra positions that we will get for the joker, two extra possible positions. Is it clear so far? Okay. So that's the main crux. Now there is an edge case. Initially, we have the segment as a single element. Okay, we have a single element. Let's say there were elements. Then we have the single element as the joker. Now, if the first operation is the joker itself, so what will happen? This, like according to the logic, if it's there, then basically it should introduce this segment should remain, and then we will have this segment, this another range, and then wait a second. Okay, so this is the diagram. Let's say I will repeat it. So initially, let's say this is the array, and this is the position of the joker. Okay, so now in the first operation itself, we are moving the joker either to the front or the back. According to the logic so far, I said that since it is the LNR, since the X is in the range LNR, we can see that it will form two extra segments, one to the left and one to the right. But in this case, you will observe that this 0 will no longer be a valid position. Why so? Because initially it was there. After this position, either the joker goes here or it goes there. So basically this position is no longer valid. Now you may ask, how does it remain when it is not of size 1? Let's say the middle one was size this. then there were these elements, then there were these elements. Okay, then when we operate on this, let's say, then this one goes there and it forms a segment. And let's leave this part for now. Okay, leave this part for now. Then this is the one, and this forms a new segment to the right. Okay, now let's say the case key, this is for this element, that it moves there. Now for let's consider about this element. When we think of this element is to the left. So basically this segment is just increased by one and this position is covered. So this will still remain a valid position only when the size of this segment is at least greater than equal to 1. Now for the rest, it's the same thing. Only this was the edge case key if if the first segment was changed in the first operation, it will form the two respective like segments to the left and the right, but the central segment will disappear. For other cases, once we achieve at least 2 in the center, we can after we will just keep expanding this to the left or to the right, and we will get segments at the front and as well as the back, and these will keep expanding themselves as well. So basically that's the question, and each time we need to just carefully consider only those elements that will remain in either of either in one of the three segments, so that we don't overcount. And as we can see, at each operation, either if it was here, only two new elements may get added. So at each step, the number of possible positions will increase by at max 2. So basically we will have some order of, basically we will have order of n way n points. That will be our answer. So okay, is it any doubts? Any doubts? No doubts, right? So I will now go on the solution, though it will be a pain because I think everyone should code this themselves. It will be pretty hard to explain, but I will try my best. Okay. Codeforces. I guess I will have to just explain it here. Okay, this was my implementation. Let's begin here. So initially, this is the input. So initially, as I mentioned before, I have three different sets. Each set, let's say I told, right, at max there will be three different intervals that will be active. So I have st of mid, which will be, this is st of m, which will be the middle segment. Then st of l, which will be the left interval, and st of r, which will be the right interval. So that's that for now. Okay, the next part, just queries input. Now I have divided the cases separately for when when there are three segments and when they are not. Let's consider the case when there are not three segments, basically when just the middle segment exists separately. In this case, let's say I took the range, right? This is L and R. Then I checked if X, which is the operation, if X lies in L and R, basically if it is included in the current range. This is the edge case that I talked about. If the size is 1, then we will just clear this set because this is no longer an active set and the answer will be decreased. And then for the other part, like I told, now we will get a new segment to the left and new segment to the right. This will be at one position, this will be at n position. Then I just check key if st of m is not empty, that is it is not an empty segment. And then either this is an empty segment or the beginning of this segment is not 1. I will add 1 to the answer, because if let's say initially only we had till range 1 to some x 1 to some x plus some k, then x was here, then this is not actually adding to the answer, though the new segment will form here, but this will just submerge. So that's just how I handled it. So if it is 1, if it is not 1, then I will just add to the answer. And similarly for the right part, if it is not n, then I will add to the answer. But irrespective of whether I add to the answer or not, I update the left segment and the right segment. uh, this is, I will just insert one element to the left segment and one element to the right segment. And this is the case when I told ki this is LR, but the X does not lie here. X is somewhere here. Since X is less than this L is just this set. This is st of m dot begin. If it is to the left, I will add 1 to the answer, and I will add this. This will increase by 1. So I will just write the L minus 1 to the set and increase the answer. Similarly, for the right, I will increase the answer and add R plus 1. That's for the case when there just exists only one segment at the middle. Now this is the case when the left segment is not empty. Basically this signifies that we have three active sets, one to the left, one in the middle, and one to the right. Okay, so if, let's say, if we get the X in the left segment, then if it is not in the left, you can see that when it is in the left segment, you cannot do anything, because if it is in the left segment, the X value, then either this contributes in itself, so it will not you add one more possible value is 1, so 1 is always already in this set, so it is not affected. And also, since the right segment also exists, then also n is also not affected. That's why if it doesn't have any purpose when X is in the set, in the interval, in the first interval. So I only check when it is not in the interval. Basically, when it is something like this is the left, this is the mid, this is the right, and I have the operation somewhere like here or somewhere. Then I just check, can I include, I will always include the next element, but will it give me a new answer? It will give me a new answer only if it was already not included in the mid segment. I just check that if the new segment that new element that I'm getting for this current segment, if it's less than mid segment's left element, then I can add it to the answer. Irrespective of that, I just add it to this set. So that's for the left segment. Now we have, similarly, we have now for the middle segment. For the middle segment, when it is, again, similarly, when it is in the mid, already we have the left and right segment. Doesn't make any sense to do any operation. Okay, so when it is not in the left, let's say when it is not in the middle segment, when it is either to the left or either to the right. When it's to the left, I just check if it's to the left, that is by just checking it with the left element. If it's to the left, then I will just as long as it is not already included in the left segment, I will include increase the answer and also include this element in the set. Similarly, for the right side, I just check it here. If it's greater than R, then I will just increase this get this new element. If it is not in the right segment already, I will just add it to the answer. Irrespective of that, I just add it to this set. So that's how I maintain the middle set. Then again we have the right set, which is like basically the left segment, just inverse. Basically, similarly, doesn't make sense if it is in the same interval, because you either contribute in this or this, like you don't get a new element. If it is here, you increase this thing once, and if it is not included in the middle already, then only I add it to the answer, and then I just add this to the right range. So that's basically the solution. The implementation could have been better. I guess you can try on your own, but that's the main crux of the question. Any doubts? Okay, no doubts. Then I will proceed to G. Okay, so basically we have 1 times, let's just draw it there. Let's just read the question once. Suppose you play a game where the game field looks like a strip of 1 times 10 power 9 square cells numbered from 1 to 10 power 9. You have n snakes numbered from 1 to n. You need to place into some cells. Initially, each snake occupies exactly 1 cell. Then we are given q seconds. The game lasts for q seconds. In each second, a snake size. Let's say earlier the snake was from L to R. Then if it enlarges, then it will grow from LR to LR plus 1. Otherwise, it will shrink. That is, it will go from L plus 1 to R. It is either this or this. That is the operation. At any moment, any snake runs. So we have to find an orientation. Basically, we initially have this long 1D grid. 1D grid. Basically, we have a number line from 1 to 1e9, 1 to 1e9. Then we need to place the snakes somewhere initially. Let's say there were two snakes. Then we place them there. With each second, let's say this enlarges. So this will now cover two cells. This again enlarges. It will now cover two cells. Then this enlarges. It will now cover two cells. Then let's say this shrinks. Since this shrinks, so this cell is no longer his. Then he will be here. Then let's say this again expands. So that's how the game will work. Now let's see how we can like run this code. Also, by the way, a good thing to notice here is n is very small, like n is 20. So somewhere like 2 power n complexity should be like visible. Okay, let's see. So basically we have this long number line from 1 to 1e9 as mentioned in the question. So we have to place, let's say first we place the snake here. Let's say the operation was something like this snake is here. Let's say we initialize the position of the snakes. Let's say we know the position of the snakes. This is the first snake. This is the second snake. This is the third snake. Then the operations go on something like this will increase till this length, then this will increase till this length, this will increase till this length. Also so the final answer is the number of cells that were occupied by some, we need to minimize, we need to find the orientation as such that the minimum number of cells are used. That is, let's say this cell that was earlier, let's consider blocks, something like this. Initially only one cell is used by a snake. The next time it expands, it uses one more cell. It expands again, it uses another cell, then it contracts. Even though it contracts, but it still used this previous cell at some point, so it will still be considered as used. So but the length of the snake will decrease increase according to the queries, which will be in sequential order. Okay, so what can we think of that? Since the n's dimension is only like 20, so what can we do? We can do something like bitmask dp or something, right? So we can check that. Let's say let's consider two snakes, I and j. Let's consider snakes I and j and their relative order of movement. Let's say let's say we will have some queries, right? Like one will increase, one plus means it will increase, minus means decrease. Let's say then two increases, then let's say five increases, let's say two decreases, then again one decreases. So for, let's consider for only two ij, you can see that if I is just before j, let's say after I place j in the order. Let's say if I place I here, I will place j next, right? So you can see that only thing that like matters for the earliest placement of j is I, because anything to the left of I does not hinder j. So only we need to check if I place I here, after how far I can place j such that there won't be any like this I will not hinder j in any way. Okay, so let's because it is irrespective of other ones. Let's say we consider for all ij pairs, we consider if I comes before j, that is j comes after I. If I is at position 0, at what position I can safely place j at the earliest, such that I don't waste any extra cells. Okay, so that, let's say that is x. So we will have this value. Let's say I call this array as scan of ij. That is, if I place I at 0th position, what is the value of x such that I does not like intersect with x throughout all these like plus minus queries. So let's, this will be I for x for this value. Okay, I will show how to calculate this later, but let's just see how the solution will look like. So this will be the value where if I place I here, I can place j at position of, j will be at let's say I is placed at pause, then j will be at position pause plus x, like basically not x, let's say just say this is as can of ij. So that's how we like find the optimal position for J that costs the least. Is it clear so far? Any doubts? Okay. So this can part is clear what it means. I will show how to calculate, but as of now, we know what this can of ij stands for. Okay. So now what will the DP states be? We will have a bit mask DP. Let's say we have like n. Let's say n is something like n equal to 5. Then we will have bits like 5 bits to represent the current state. Initially we'll, let's say the base case of the DP will be like the DP dimension, it will be a 2D DP. DPIJ. What will be DPIJ? What will DPIJ mean? So DPIJ means I will hold the mask, holds the mask of elements, a mask of snakes that we have already considered in the prefix. So let's say I will look something like, if n is 5, I will look something like 0 1 0 0. That means we have already taken two snakes, and the jth dimension will be what was the last snake that we took. That is, in this case, let's say I took this is 0th 1 2 3 4. This is the second snake, this is the 0th snake. Let's say when we achieved this mask of 10100, the second snake was the last snake that we took. So the j will so this DP state will be DP of 10100. This is in binary, but the state will be in decimal obviously. Then this j value will be 2, because 2 was the last snake that we took. Now since we see that we need to place 3 more snakes in the masks, because in the mask only two are we have only 2 set bits, so we need to place three more snakes. Let's say we try to place this snake after this 2, right? Because the previous one was 2, so we will try to place this first snake. Then from can to j, let's say wait, so this DP, what does this DP store first? This will store the minimum position where we can have this mask with this as the last in this, in 1 to 1e9 grid. So the essence of 1e9 is that it is an infinite grid, and we will always like almost be able to place it optimally with the given condition, because we have n equal to some like 10 power 5 order. So basically, 1e9 has no other significance other than meaning that we can always find like orientation. So initially, let's say we place the 0th snake first. So we place to get this mask, we first place the 0th snake, then we placed the second snake, and now we will choose which snake to place. Let's say the 01 was here, then we place this 2 here. Okay, so we will now have this value. So basically, this is the earliest, such that we have this mask, and 2 was the last snake that we placed. Okay, so now I will try to, let's say I try to place the first snake. So with this was the previous position, then if I just add can of 2 comma I 2 comma 1, I will get the next position where I can place the first snake safely, so that 2 does not obstruct 1, or like they do not intersect at any point. So that will be the position for 1. So I will just like now, since I also took 1, so how will the mask update? The mask will now be 11100. Okay, so now the mask updated. Now this will be, now the previous will be 1, and we can get the minimum. It will be the previous DP. Let's say, let's just use DP here. DP of 10100, and then 2 plus can of what did we have? We have 2 previously, and now we just placed 1. So that's the DP transition. That will how the DP transition look like. So I will just write the general DP transition. So the DP transition is DP of I comma j, then I place DP of okay, so it will be the minimum of for all k, such that k is not in I, k is not in I, not in I. Then I will do k of I or 1 to the power of k, the I or 1 to the power of k with k as the previous. I will then take minimum with dp of ij plus can of j and k. Note that k should not be present in the mask that we already had. So that was the dp transition. So now how to calculate this can array? Okay. So any doubts so far? Okay. So how do we calculate this can array? Let's say we place this is the place where let's just consider j as the previous snake and k as the current snake. This was previous, and after that we place k. So let's say I just put j at 0. So the segment of j initially is 0 0, and let's say I put k right next to it. I can't place it any before because it will like change the order of the question, order of the like form that I'm taking. Ki j comes before k. So the earliest that we can place k is 1 comma 1 if I place it in 0 comma 0. And the extra amount of blocks that we took was just this one because till this was already considered in previous dp state. So we'll only get this extra state. So let's consider the extra states, extra like cells as d equal to 1. Now we'll iterate through the sequence of operations that we have. Let's say we will have some kind of operations like uh, we'll have some other operations on some other snakes that we don't, that really doesn't matter because we only focus on j and k. Then we will have something like j plus, then have like k plus, then we'll have something like j minus, then k plus, something like that. Now what will j plus do? J plus just increase the segment of j by 1. Increase the segment of j. Let's say if it was 0 comma 0, it will become 0 comma 1. Now you can see it become 0 comma 1, and at this moment the other snake which was k is at 1 comma 1. So this causes like this is this they have a cell in intersection, and according to the question we cannot have intersecting snakes. So basically what does it mean? Basically we will have to shift the previous snake one to by one position. So I will just add one to the new snake. So basically it was 0 1. So I will do it from now 2 comma 2. Initially it was from 1 comma 1, but since we saw that it causes a like intersection, I just pushed it once to the right, and I will increase d because you see initially it was at 1 comma 1. Now since we shifted it by one position, so d will increase. So d is now 2. So it took two cells. If at some operation it does not hinder, let's say it was this, then I increased, it was this, then I increased 1 comma 2. Then let's say I decrease this. Let's say this was now 0 comma 1, this is now just 2. Then I just increase it again, but now you can see that it does not cause any problem because it was already like it was at 2 comma 2, right? So 2 comma 2, it will now become 3. Then basically it will become 2 comma 3. Then I just reduced it once and increase this one once, so it will become 0 1 2, and this just remains 3. So you can see that it does not hinder. So basically the only time it hinders is when what do you call it, when we have an obstruction and then we need to increase the answer. So that's the main idea, and then we can just this is how you calculate the can array, and after that you can just solve the answer. Is it clear? Okay, so I will go over the code now. uh, okay. Okay, so initially I just take the input, I just convert the op array such that it does not have any character. I just, if it is if it was plus, then I just indicated it with 1, otherwise it is 0. Then I initialize, as I told, I initialize it with 0 comma 0. Then I initialize the, this is, let's say I'm calculating the need of here I have used the term need for can. Basically, I comes before j. So this is the value of initially pos I is 0, 0 and pos j is 1, 1 and d is initially 1. Then I just operate on both of them. Let's say this was initially I. If it is an operation on I, that means that if it is not t, that means it was minus, then just the left pointer will increase or for the ith snake. So I just increase it with not one. Basically that means ki when it's minus it will increase the left one, otherwise it will increase the right one. And if it intersects with that one, that means we need one more extra block is wasted. Then I will shift the entire jth snake by one and increase the answer. Similarly, if there is no if it is for an operation for j, it doesn't matter, so I just increase it with t. Then the cost of I will be pos of I, cost, okay, the cost array. So basically now after this dp is calculated, I will know that the final snake that I took was this was the final snake. Since that is the position that we can start this, after that the cost thing is, okay, if this is where the snake started, how much extra it will take to the right because of the operations of the query. It might increase till this then start decreasing. So that is what I calculated by cost I. It can be directly calculated by this thing as well, because since pos I is increasing, so at the end whatever the value of pos I was is what it will form, it will need extra. So I just took it as cost of I as pos of I dot ss, and then the need, that was the can ij, which will be which will be d. Then this is the initialization of the dp, that is this is the size of the mask, then the previous one, and I initialize with a very large number. Then this is the base case. The base case is just key, initially I have just one bit set and that was the previous element, and it just cost me one cell just to place it there. Then I okay, then I will just do the I will go over all the masks. Then this was the previous, j is the previous one, k is the current one, k should not be present in the current mask. Then I will just take min with I and I will add this mask to there, and k will be the previous one that we have added, and dp of ij plus equal to this need value that I have shown before. Then when calculating the answer, I will just check the answer. This was the earliest we can start this ith snake when it is the last snake, and then I will need cost of I to operate on it to go to the right. So that was the question. Any doubts? Okay, then my part is done. Thank you.
Simon record all record কৰিছা? কলটো এণ্ড কৰিব পাৰি নেকি, মানে কলটো এণ্ড কৰিব পাৰিনে? আচ্ছা আচ্ছা, ঠিক আছে, খতম কৰি দিয়ক না।
हाँ हाँ